At the southern tip of Hawaii's Big Island lies one of the rarest beaches on Earth. Unlike the white sands formed from coral fragments or the black sands created by volcanic rock, Papakōlea Beach appears green. From a distance, the color seems almost impossible. Up close, however, the explanation is contained within thousands of tiny mineral grains scattered across the shoreline. The beach is green because it contains large concentrations of olivine. Peridot, the gemstone variety of olivine, is prized around the world for its distinctive green color. Most of the grains found at Papakōlea are not gem quality, but they are made of the same mineral. What appears to be green sand is, in reality, an entire beach composed largely of microscopic fragments of a gemstone. The story begins nearly 49,000 years ago when the nearby volcanic cone, Pu'umahana, erupted. The lava and ash produced during the eruption contained abundant olivine crystals. Over thousands of years, waves and weather gradually eroded the volcanic deposits. The lighter volcanic material was carried away, while the denser olivine crystals remained behind. The result is one of nature's most effective sorting systems. Papakōlea Beach is not simply a green beach. It is a geological record of volcanic activity, erosion, density, and time working together over thousands of years. Yet the beach raises another question. If olivine is concentrated here, where did the crystals come from in the first place? The answer lies far beneath the beach itself. Long before those green grains reached the shoreline, they formed deep within Earth's mantle, the vast layer of hot rock beneath the crust. In fact, olivine is one of the most common minerals in the upper mantle. Most peridot begins forming tens to hundreds of kilometers underground at temperatures exceeding 1,200 degrees Celsius. Under ordinary circumstances, these crystals would remain buried forever. Volcanoes provide the mechanism that brings them back to the surface. As magma rises upward, it can transport olivine crystals along with it. If the ascent happens quickly enough, the crystals survive the journey intact. In this way, volcanoes act as geological elevators, carrying material from deep within the planet into environments where humans can eventually discover it. Occasionally, the process becomes dramatic enough that olivine appears to rain from the sky. The phrase sounds like something from mythology, but the underlying geology is real. During volcanic eruptions, magma, ash, rock fragments, and mineral crystals can be launched high into the air. As the eruption plume cools and gravity takes over, these materials fall back to the ground. In eruptions containing abundant olivine, fresh green crystals may accumulate around volcanic vents and lava fields. A modern example occurred during the 2018 eruption of Kilauea in Hawaii. News headlines around the world reported that the volcano was raining gemstones. While somewhat sensationalized, the reports were based on a real phenomenon. Residents found fresh olivine crystals scattered throughout eruption deposits, allowing people to pick up fragments of Earth's interior that had only recently emerged from the volcano. Some eruptions go even further. Volcanoes occasionally bring pieces of the mantle itself to the surface. These fragments, known as xenoliths, often contain olivine-rich rocks called peridotites. During explosive eruptions, these mantle fragments may shatter, releasing individual crystals that become part of the ashfall. In a very literal sense, pieces of Earth's mantle can fall from the sky. Remarkably, Earth is not the only source of olivine. Certain meteorites, known as pallasites, contain spectacular green olivine crystals suspended within metallic iron-nickel frameworks. These meteorites are thought to represent material formed during the earliest stages of solar system history, more than 4.5 billion years ago. When a pallasite meteorite falls to Earth, olivine arrives from space. This gives peridot an unusual distinction among gemstones. It can originate from two extraordinary places, deep within Earth's mantle and beyond Earth itself. Few gemstones can make a similar claim. Long before geologists understood where peridot formed, people were already fascinated by its color and rarity. As the stone moved between cultures, new meanings accumulated around it. Ancient Egyptians called peridot the gem of the sun. One of the most important historical sources was Zabargad Island in the Red Sea, where peridot was mined and traded throughout the ancient world. The stone became associated with protection, prosperity, royal authority, and solar power. In medieval Europe, peridot was frequently mistaken for emerald. Many treasures once believed to contain emeralds were later discovered to be peridot instead. Today, major deposits are found in locations such as Arizona and Pakistan, and the gemstone remains valued for its vivid green color and relative rarity. Yet geology and history are only part of the story. Like many gemstones, Peridot has accumulated symbolic meanings across different cultures and traditions. Across many traditions, Peridot became associated with growth, renewal, emotional healing, and abundance. It is most often connected with the heart chakra, and in some traditions, the solar plexus chakra, linking the stone to both connection and personal growth. Whether these associations are viewed spiritually, psychologically, or symbolically, an interesting pattern emerges. The meanings people assign to Peridot often mirror the geological story of the stone itself. It forms deep underground, it remains hidden for long periods of time, it emerges through transformation, and eventually it becomes visible at the surface. Growth emerging from depth is both the symbolic message and the geological reality. The relationship between people and place appears again in Hawaiian traditions surrounding the land itself. One of the most widely known stories is the modern belief often called Pele's curse. According to the popular version, visitors who remove rocks, sand, shells, or lava from Hawaii will experience bad luck until the objects are returned. Many visitors have mailed rocks and sand back to Hawaii, often accompanied by letters describing illness, financial problems, travel mishaps, or personal difficulties they believe occurred after taking the items. While scholars generally do not consider the modern form of Pele's curse to be an ancient Hawaiian belief, the story reflects older cultural values emphasizing respect, stewardship, reciprocity, and relationship with the land. The deeper lesson may be less about punishment and more about perspective. Not everything exists to be taken. Hawaii is not the only place where stories, traditions, and laws have emerged around the removal of natural objects. Similar ideas appear in protected beaches, national parks, sacred mountains, and culturally significant landscapes throughout the world. Protected beaches in Sardinia prohibit sand removal. National parks throughout the United States forbid visitors from taking rocks, fossils, and other natural materials. Similar traditions exist in Australia, New Zealand, and around sacred mountains such as Uluru, Mount Fuji, and Mount Kailash. Again and again, different cultures arrive at similar conclusions. Certain places deserve respect. Certain objects belong where they are, and visitors are guests rather than owners. Viewed through a geological lens, a grain of green sand is the product of deep geological processes. Through an ecological lens, it may be part of a larger system. Through a cultural lens, it may belong to a landscape with deep historical meaning. The same object can exist simultaneously within multiple stories. Perhaps that is what makes Peridot so fascinating. It is a gemstone born in darkness and revealed through fire, a mineral that can emerge from the depths of Earth or arrive from beyond our planet, a crystal connected to geology, history, mythology, and culture all at once. And on a remote Hawaiian beach, it remains scattered across the shoreline as a reminder that some of the most extraordinary things in the world are not hidden in museums or vaults. Sometimes they are simply lying in the sand, fragments of ancient volcanoes, products of deep geological processes, and reminders that every landscape contains stories waiting to be discovered. All waiting for someone to stop, look more closely, and ask why a beach might be green.